Okay, I wanted to talk about the last component I have. I haven't talked about it yet, but I got it in. So all it is a temperature sensor. So I've got it right here on the board already set up and working, but we're going to do a quick review over it. You can see it's a TO92 package, nothing fancy, 3 little pins. If you look closely at what's engraved in it, you'll see its part number, MCP 9700A-E. And we need to know information like that because we need to know how to use these. I'm pretty sure I've used these before, but I can't remember if it was this exact one. It was similar. So what I had to do was Google it. So I Googled it and I found here on DigiKey they had the exact part, which it so happens is where I bought it from. But they've got the data sheet. That's the only reason I'm here. So when I click on the data sheet, I get this. All kinds of fantastic stuff. Data sheets are extremely important. The first thing is this. It's just a pinout of it. And I can see we've got our input voltage, our output voltage, and a ground. What we need to go back and look at is the input voltage. So we look here, we see it's an input voltage range of 2.3 to 5.5 volts for the 9700. Now, we see 01 here, that's not what we have. We have the 00. While we're here, we also see something else extremely important. 10 millivolts per degree Celsius. This will definitely be needed when we do our Arduino code. But as you can see, this has a 40 to 125 degrees Celsius, negative 40 to positive 125 degrees Celsius, but it also has up to 150 here, and these numbers will pop up here in a little bit. We'll scroll down and look and see where that comes in, but they give us all the base information. Most of this stuff isn't important to you, but definitely look through it. What is important to us is when we get down here, when they start talking about the pins. Ground is, of course, V out. They kind of recap, but V out actually only outputs a voltage from 100 millivolts to 1.75 volts. This is important. So this is the 9700 series. And then VDD, we already talked about its input characteristics. If we go down here a little bit further, application information. So they start going over some of the stuff we already covered, 10 millivolts per degree Celsius. They tell us how V out is basically internally calculated. They talk to us about improving accuracy and then some other application-based stuff. But this right here, a key little thing, the output voltage at 0 degrees C's is also scaled to 500 millivolts typical. So we have our range 40 to 150, and 0C should be at 500 millivolts. And if we've got 10 millivolts per degree Celsius, 10 milli times 40, which is the difference from here to here, would be 400 millivolts. And if you remember, this thing only outputs from 100 millivolts to 1.7. So 100 to 500 is 400. That's that range. But then if you look from 0 to 150, that'd be 1.5 volts. And we go from 500 millivolts to 1.75. That's slightly off, don't you think? 1.25 volts. Well, if you remembered up there, all the way back at the top, we had where it states 125 here. So this, if we pay a little bit closer attention, this is MCP 9700, SOT 23, and SC 70 only. We've got the TO 92 package, so that doesn't apply to us. So we're here. So now that we know our pinouts, we can connect it. And we also know all of our operating information, so we can program it too. If we come back and look at our circuit, we have our TO92. So we've got our VN, which if you look here, I'm connected to our 3.3 volt input, our output from the Arduino. So that's what we're going to power with. This thing's such low current draw, I'm not worried about using this to power it. Then we have our V out, which is coming back to an analog read because this gives us a voltage range. And then we're connected to ground. Pretty straightforward. So now we can go back and look at our code. So when we do an analog, or well, some of the basic stuff, you know, as you would expect, we had to declare. I went ahead and made a variable for which pin we're using. That way when you see an analog read later, you know what we're reading. I've added a variable to hold the temperature. Now, I had to use a float. Why? Because we have decimals, and we also potentially at the end have negative values. So float works best for that scenario. Now you'll see here I've got this other thing, temp degree. Well, this comes into play when we talk about the Bluetooth aspect. I'm going to use this for differentiating between Celsius and Fahrenheit. So we come down here and I do an analog read here, nothing fancy there, but then after that it goes into the Bluetooth stuff, which really is that, but you know, we're not going to worry about that right now. Here's the fancy stuff. So I set the value of temp, and I made a function for it this time because I'm trying to clean up my code a bit and moving stuff out of the way. I still got to do it with some of this other stuff, but I passed a couple values through there. This is what's read from the analog read, so it's a number between 0 and 1 or 1023, and then this is that Bluetooth value, which is going to trigger whether it pops back out as Celsius or Fahrenheit. So I'm going to go to this function that I created. So down here I've got my function tempcal, and it's going to return a float. That's because of that decimal. And you can see the two variables that are being passed into it. I got my temp, and I declared as a float, and I've got, or my analog read. I just went, it had to be declared as a float even though it's just an integer at this point, because later on when we write back to it, it ends up being a float. So the first thing I do is I declared a temporary value to use for the calculation, and at that calculation what I did is I divide the analog read reference voltage by 1023 to find out what each increment relates to as a voltage. And I actually measured it. It didn't come out to quite 3.3. This gave me a little bit more accurate voltage reading. Then after that, I multiplied it by that analog read number. And it was probably around, you know, 300 something, I think is what it came out to be. And so that gives me a voltage. In this case, it was coming out to about 0.8 millivolts. It was coming out to 0.8 volts, excuse me. That first 0.1 volt was useless because it doesn't output anything below 0.1. And then also we had a shift from 0.1 to 0 because we want to read our number at 0. That way we can end up with negative or positive values. So I had to offset it first. 0.5 millivolt was at 0 volt range. After I did some playing around, I found out that 0.5 wasn't the 0 point for this one. If I had a more controlled environment, I could test it, but this room is actually pretty consistent, right about, I think it was 72 volts, or I mean 72 degrees Fahrenheit. So when I shifted an extra 0.1 volt, it came out exact. So I went ahead and went to 0.6 volts, and then from there I had to divide by 0.01 or 10 millivolts to convert it to degrees Celsius. And now I take that Bluetooth value to tell me whether I want Celsius or Fahrenheit, and if it's set low, Celsius; if it's set high, I convert to Fahrenheit, and then I return the value back up here. And then that value is then stored in temp, and then I can save it in Bluetooth to send to my app, or I can come down here and print it out in my serial monitor. And if I bring up my serial monitor, we can see where, I was doing some testing, and the last time I was running it was at 23.66 degrees Celsius. And if we come here, 23.66 degrees Celsius to Fahrenheit, Google tells me that's 74.588 volts Fahrenheit. And if I take my handy dandy infrared thermometer, the temperature currently in here is 72.7 volts Fahrenheit, or degrees Fahrenheit. So we're pretty close, slightly off, but this room temperature does vary by about a degree. And also, if we come back here, there is an accuracy range, and if we scroll down, let's see, where is it? Sensor accuracy at 25 degrees Celsius plus or minus 1 degree Celsius. And plus or minus 1 degree Celsius is about 2 degrees Fahrenheit. So I'm pretty close to 25 degrees Celsius, so there should be a variance of about 1 degree Celsius, which could be about 23 degrees Celsius, which puts me right at within tolerance. So that's my temperature sensor. It's hooked up, it's reading, it's working. It gives me local temperature. This is usually, you could also take this exact same setup and build yourself a smart thermostat at home or something fancy like that.